Yesterday you got the homework for AS level or minor chemistry about alkenes. This is the discussion of the homework. Okay, so I hope all of you already turn in all your homework properly on Google Classroom. Okay, let's see number 1. Alkenes are used to make addition polymers. The repeat unit for addition polymer is shown below. We count here, there are 3 carbon atoms. And then there is written here addition polymer. Addition polymer only occurs with double bond. So if there are 3 carbon atoms, so the monomer must be a propene. And then number 2, polychloroethene, so there is chlorine, has the repeat unit as below. So again, polychloroethene, this one is written ethene, ending with ene. It shows it is an alkene, so it contains a double bond. This repeat unit can be written as CH2CHCl. One way to dispose of polychloroethene is to react it with oxygen at high temperature. This is called as incineration. We know that incineration completes the equation for the reaction taking place during incineration. Okay, so this one during incineration, the CH2Cl, CH2CHCl plus oxygen gas burn undergo complete combustion. But the complete combustion is not only producing carbon dioxide and water, but there is also a hydrogen chloride. Hydrogen chloride is the gas. So hydrogen chloride is a harmful gas. It is a strong acid gas. It is not environmentally friendly. And then number 2, the research chemists have reduced the environmental impact of incineration by removing the HCl formed from the waste gases. Suggest a type of reactant that could be used to remove HCl. HCl is an acid, so it can be removed by reaction between acid and base, or acid and alkali can be acid and carbonate. Acid react with alkali to form salt and water. Also, acid react with base to form salt and water, but acid react with carbonate to form salt, water and carbon dioxide gas. I hope you still remember what is the difference between alkali and base. Okay, next, number 3. Okay, the disposal of polymers cause environmental damage. Research chemists are developing polymers that will reduce the environmental damage and increase sustainability. Describe 2 ways in which chemists can reduce this environmental damage. There are many methods to reduce the environmental damage. One is using photodegradable polymers. Of course, right now there is a plastic bag which is easy to be degradable, but it is biodegradable or it is easy to decompose. And then next can be used technique of cracking polymers or using chemical feedstock. What is the common chemical feedstock? Is from naphtha. And then there is still another way, making polymers from plant-based substances. There are many research in high school level, also in university level, how to make an artificial plastic bag from cornstarch, from other starch, from plant based. And then designing process with high atom economy or reduce waste products during manufacturing. And then we can do sorting or recycling the polymers. Okay, so there are many ways. You have to write only 2 out of so many. Okay, next question. Alkenes are unsaturated hydrocarbons used in industrial production of many organic compounds. Complete the flow chart below to show the organic product formed in each addition reaction of methyl propene. So, methyl propene with bromine, methyl propene with bromine will become 1.2 dibromo 2 methyl propane. Okay, so forming this structure. Bromine, this one will will not undergo using Markovnikov rule. Why? Because there is no hydrogen in Br. So the bromine will occupy both the empty. This one, what is happening in this one? So there is the mechanism is electrophilic addition. The high electron density of carbon-carbon double bond will repel the electrons in the bromine. That makes one bromine become electrophile and then the other bromine become nucleophile. Similarly with hydrogenation of addition with hydrogen gas in the presence of nickel catalysts, the product will become methyl propane or 2-methyl propane. Okay, next with HBr. With HBr, we see here, this is using a Markovnikov reaction. Using Markovnikov reaction, this one will probably will make the product. Why? Because according to the Markovnikov rule, the hydrogen of the hydrogen halide will attach to the carbon that has already hydrogen atoms in it. So in this one, the left side of the carbon has 2 hydrogen, in which the right hand side of the carbon does not have hydrogen. So the bromine will attach to the carbon that does not have hydrogen, and then the hydrogen of the hydrogen halide will attach to the carbon that has already hydrogen atoms. But this one, there is a side product. The side product is the opposite, not following the Markovnikov rule. Okay, next, number 5 on the last page. Curly arrows are used to show the movement of electron pairs during chemical reactions. Use curly arrows to outline the mechanism for the addition reaction of methyl propene with bromine. The structure of the methyl propene has been drawn for you. So this one. So in here we have to draw the curly arrow. It has high electron density that repels this bromine. The electron in this bromine that makes this electron in the bromine is taken by this bromine. That makes this bromine become an electrophile. The electrophile will attach to the carbon here. And then this carbon become a carbocation. This bromine, which is a nucleophile, has an excess extra electron. This extra electron, the pair of electron, can be donated to the carbon. It is not donation, it is a dative covalent bond. So what are the importance here? We have to show the carbocation, we have to show the dipole of the bromine, and then we have to show the curly arrow repulsion, and then we have to show also the repulsion of the double bond, the electron density to the bromine that forms a bromine electrophile and bromine nucleophile. Next question, number 6. Fluoroalkenes are used to make polymers. For example, PVF is used to carbon to make a non-flammable interiors of aircraft. Draw two repeat units of PVF. PVF showing all the bonds. The structure, the condensed structural formula of PVF is CH2CHF. Okay, so from this one, CH2CHF, this must have a double bond. Why does it have a double bond? Because CH2C, there are 3 atoms. In fact, one carbon can make 4 single bond. So there should be 4 atoms. But in here is only 3 atoms. It means the 1 electron of the carbon is making double bond. Okay, so this is the polymer of the PVF. And then draw the structure of the PVF. As I told you, there is a double bond. Okay, carbon and fluorine will have a strong bond. It has high energy, high enthalpy, so it's not easy to decompose. That's why it is called as non-flammable. Okay, this is the discussion of the homework.